Machine Pencil Cartography. My channel's goals involve teaching people how to navigate in diverse environments. For this reason, I have taken an interest in navigations of many different types. The history of naval and maritime traditions are thousands of years old. Therefore, the advent of these new modern ships, which are constructed with steel hulls and are propelled by the power of diesel fuel, is relatively recent. We should recognize that our culture of maritime transportation has more experience piloting sailboats, which were made out of wood, than it has piloting these luxury ships. I had little or no interest in sailing until I found out that sailboats are powered by natural energy sources. We may observe that navigating costs money, and that we may pay for every mile that we travel. So, when I discovered that these navigational vessels were powered by natural sources of energy, I eventually realized that this means that these maritime vessels are more affordable to operate. The fuel costs are significantly augmented by the power of the wind. This is a highly titrated result, and even though sailboats are less glorious than their diesel-powered alternatives, the potential benefits of sailboats are undeniable. Navigation and orienteering can be an expensive sport, equally as expensive as any other hobby or occupation. Therefore, it is impossible to deny that the prospects of sailing for zero energy costs for days or weeks on end in the middle of the ocean is an attractive prospect. After all, it is difficult to do better than receiving miles for free. We may attempt to comprehend how high winds will affect the operations of terrestrial navigators during long transcontinental road trips. We should always remember that during a storm, we are not only coping with the effects of pouring rain, but we are also coping with the effects of high winds. Automobile designers make large efforts to study the rheological attitudes of their vehicles, and they even construct large wind tunnels so that they can scientifically test the performance of their aeroframes in a lab environment before they commit to mass manufacturing these vehicles to fulfill large production orders. The first and most important test case is known as the headwind test case, and the headwind test is relevant when the carrier is driving down an expressway, perhaps at 100 kilometers per hour, and the headwind will occur over the windshield of the car. The headwind will occur during normal operations due to the speed of the vehicle alone, and this is why the headwind is such an important study. It is because the headwind study covers the performance of the vehicle in the predominant orientation of rheological current. The second most important test case for wind tunnel studies is known as the crosswind test. This test will consist of placing the carrier into the wind tunnel at a perpendicular orientation to the direction of the current. The crosswinds are considered much more dangerous because the crosswinds can affect the vehicle's balance, and catching a strong crosswind, if you aren't prepared for it, may cause your vehicle to veer off of the road to the leeward side, away from the wind. They call this issue side slip, and the potential results can include car crashes. The solution to this problem is that the driver must counter steer, which is a technique that will involve steering into the wind to counteract the force of the crosswind. In the most famous example of crosswind compensation and counter steering out there, an airplane must land on a runway during high winds. This maneuver involves steering into the wind during touchdown. There is one more condition called a tailwind, and this one is most relevant to sailboats. In ideal conditions, the tailwind will allow the sailor to navigate running downwind, which is obviously the most straightforward course possible for a sailor. The tailwind is admittedly not very interesting for terrestrial navigations. There is one final example of the way that the wind affects navigations. In one of my videos, I have discussed these things called tidal diamonds. When maritime navigators are plotting courses in the ocean, it is common for the navigator to include an examination of the currents that are present near the ports, and they will interpolate their tidal diamonds during the process of charting these courses. The technique is called set and drift. This technique involves compensating for the currents of the ocean. The navigator will begin by charting their true course, and this is the course that the navigator intends on taking. They select this course because this course is in direct alignment with the navigational helm. After this, the navigator will account for any water currents or air currents that were present in the area. Then the navigator will attempt to account for the speed and direction of the ocean and wind currents. The direction and intensity of these currents are known as the drift current. The set and drift technique will involve counter steering during the entire course of navigation because the navigator is anticipating the strength of these crosswinds and continually applying course corrections during the entire duration of their trip. When the course is completed, there is a track known as the course made good, and we may imagine that the navigator may review their own performance, perhaps with an electronic logging device. And the course made good will reflect how well the navigator performed during their continual course corrections. The better the navigator performs, the more the course made good will resemble the true course. Since the true course reflects the goals of the navigator, the true course is the maximum standard of performance available. Finally, just for fun, during the research for this video, I have explored the possibility of using blow carts or land sails, which are these cool devices that allow people to harness the benefits of the wind as a natural energy source even while they remain on land. While I admit that this is an experimental technology that likely will never surpass our modern automobile technologies, the benefits of this technology still allow us to harness the power of the wind on small scales, making this a feasible and, most importantly, affordable hobby, and perhaps an exciting way to spend your time if thrill is your chief goal. My goals for this essay were to inform my audience about the nuances of navigating in strong wind currents. Thanks, guys. This has been Machine Pencil Cartography, signing out.